For the integral from 0 to 1 of sine of pi x dx, using the midpoint rule, we will set up m sub n. This means using the midpoint using n rectangles. And then use the expression for m sub n and approximate it with n equals 100 and then n equals 1000. First, this definite integral is over the interval 0 to 1, where a equals 0 and b equals 1. The width of each of the rectangle is delta x equals b minus a over n. N is simply n for now. If x sub 0 is 0, which is the left endpoint, then x sub 1 is 0 plus 1 over n, 0 plus delta x. X sub 2 is 0 plus 2 delta x, which is 2 over n. And then x sub 3 is 0 plus 3 of delta x, so this is 3 over n. But these are only the endpoints, not the midpoint. If we want to use the midpoint, then first we compute the midpoint of the first interval, which is 0 plus 1 over n, and then we divide it by 2. So this is 1/2 of 1 over n, or 1 over 2n. Using this first midpoint at the base, the first midpoint x sub 1 bar is 1 over 2n. X sub 2 bar is therefore 1 over 2n plus 1 delta x, but delta x is 1 over n. X sub 3 bar is 1 over 2n plus 2 of delta x, but delta x is 1 over n. Therefore, x sub I bar is 1 over 2n, which is the first midpoint, plus I minus 1 times 1 over n. It has to be I minus 1 in this case because we observe that x sub 3, if the subscript is 3, we would use 2 delta x. And if the subscript is 2, we would use 1 delta x. Therefore, if the subscript is I, we would use I minus 1. And so this is x sub I. With this x sub I, we can find the corresponding height. But before we do that, it is a good idea to simplify this. This is 2n as a common denominator, 1 plus I minus 1 times 2. And so this is 1 plus 2i minus 2 over 2n, or 2i minus 1 over 2n. But this is only x sub I bar. The corresponding height is f of x sub I bar, which is sine of pi times x sub I bar. X sub I bar is 2i minus 1 over 2n. This is sine of 2i minus 1 over 2n times pi, but this is only the height. The midpoint sum m sub n is the sum at I go from 1 to n of the height, which is sine of 2i minus 1 over 2n times pi times the width, but the width is 1 over n. We now have an expression for m sub n. If we want to approximate m sub 100, we simply replace n with 100. M sub 100 is the sum as I go from 1 to 100 of sine of 2i minus 1 over 2 times 100 times pi times 1 over 100. Similarly, m sub 1000 is the sum as I go from 1 to 1000 sine of 2i minus 1 over 2 times 1000 pi times 1 over 1000. When we use a calculator, we will need to put the extra set of parentheses around the argument of this sum. Using decimals.com, m of 100 is approximately 0.636646 rounded to 6 decimal places. M of 1000 is approximately 0.636620. Using decimal.com, we would simply type the word SUM for sum. It is automatically displays n equals, but we can replace n with I. We want to go from 1, I equals 1, to 100, and then we would type in the function sine of, make sure we open a parenthesis. The argument of sine is 2i minus 1, so this is 2. We set up the fraction first. The denominator that we have earlier, it was 2n, but n is 100. The numerator is 2i minus 1. We simply typed 2i minus 1 in the numerator. Don't forget that we still have pi. And then we take this and multiplied 1 over n, but n being 100. And so we get 0.636646. For n equals 1000, we simply replace 100 with 1000.